So how does this all work? So we have a network here. It's a mesh network, which is a little unusual, but completely acceptable and usable within a SDN world. But by default, no traffic is allowed to communicate on this network. Nothing gets past the port of the switch besides ARP traffic on this network. And that's just the heartbeat of the network. It's required. But if I want the PLC in the lower left to talk to the SCADA box on the upper right, I need to now create a rule. So I put a rule in the controller, and the controller does the rest. It talks to the switches. It sets out what are called flows in those switches to make sure that the data can pass from one location to another. If for some reason that connection breaks, we reroute it. We know that it's no longer communicating or able to get through, and the switches and the controller communicate with each other, and we lay out new flows. It may not be as quite of a short of a path like in this example, but it's perfectly acceptable. And then because we manage devices by the endpoint, not by switches and not by ports, if you happen to move a device either from one port to another on a switch or even one switch to another, it's fine. It finds that endpoint and it reflows it, and now you're communicating again. So gone are the days of plugging into the wrong VLAN and everything shuts down. You just plug it into any port on that switch and you're good to go. And so this is the high level, the sort of 100,000 foot level. Let's go down one level and I'll show you a little bit about the mechanics of how this works. And this is a very simplified view of it. There's networks are very complex, but I think it'll get the point across. So if you have traffic on your network that is allowed, as in there's a rule in the controller that says this is okay. So this PLC and this HMI want to talk to each other via Ethernet IP. And you notice I mentioned the protocol because Ethernet IP may be okay, but FTP isn't, that sort of a thing. But the first time the switch sees that Ethernet IP traffic, it queries the controller. What do I do with this? And the controller says, I have a rule for it. It's okay. Pass it. It lays a flow in and it passes that packet. Then, because this question comes up, do we ask every single packet? No, we don't. If the switch now remembers. So if you lose connection with that controller, the switch now just doesn't need to ask next time it sees the packet. And every time it sees the packet from then until a rule changes or something, the switch just says, okay, I will pass that. And that allows for, the Ethernet level speeds that we're talking about are used to because we don't request it every single time. This also gives you a level of resiliency in your network because the controller is not required on the system for the network to function. The network will continue to function without the controller. And then you bring back the controller. But I mean, the most important thing to us is for the network to continue to run and produce, allow people to produce whatever product they're producing, whether it's energy or, snack bars, anything in between. If you have a bad actor or somebody just trying to get in, which we'll just call them a bad actor because it might be an OEM for a machine. It might be some engineer that's not supposed to be making changes that does it anyway. But if you have a bad actor in there, you have a new device or an existing device talking in a new protocol, and there's no rule for it, the switch will query the controller just like it did with allowed traffic. But the controller say, I don't have a rule for this. And so that communication stops at the port. This is how we microsegment the network. They're not allowed access to other things in the VLAN. They are not allowed access to anything except for what is on that, what it's specifically allowed by the controller. So this blocks it at the port. It also logs this. It gets there's an entry put into our event log as well as made available to other products if you so choose through a northbound API. So audits are created for this. So let's back up to our two form factors that we have. We've got the OT network controller, which is a piece of software. It typically runs on the virtualization stack. Some companies will run on a bare metal computer. It can manage any OpenFlow capable switch, and it's really appropriate for any size installation if you want to. And high-speed applications are also fall into this. It's not that it can't do slow-speed ones, obviously, but I'm going to recommend it for high-speed applications because our security appliance is a much smaller system. It's got the OT network controller software package and a 7-port switch integrated into one thing. When you receive this package, they are pre-set up so they're communicating with each other, and the switch has been adopted by the controller. It also can manage any open flow capable switch. You don't lose that. You can make larger networks than just this box, but it's really targeted at remote assets. So, small energy locations, windmills, grain, cement, proof of concept testing. People will want to use this in their labs to play with it. It's a nice, easy box to have for that. If you've got a problematic network segment in your network and you want to try this out and try to fix it, something that keeps you up at night, this is a great solution for that. Everybody asks about this. Essentially, what are the specs of the box? And it is got 5 just regular RJ45 ports. It's got 2 of the SFP ports. It has a dual power supply capability. I'm running mine on my desk next to me at 24 volts, but 20 to 54. It's got a pretty wide operating temperature range of -40 to 70, and pretty wide relative humidity range, non-condensing. Some decent certs on it, and then it is a DIN rail or wall mount box. I will hold it up one more time so you can see for reference. Like I said, can't see myself, so give you an idea of the size of it and the ports, but certainly be happy to provide any information that people want afterwards.